In this chapter, we will learn about a bunch of techniques called dimensionality reduction techniques by building upon some linear algebra that we just learned. And what is dimensionality reduction and why should we learn about it? So we realize that we can visualize data in 2D and 3D using our simple scatter plots, right? If you recall what we learned in our exploratory data analysis and plotting, we learned that we could use scatter plots to visualize data in 2D and 3D. For 4D and 5D and probably even 6D, we could leverage pair plots to get a sense of how the data is. What if you have 10-dimensional data? We realize that if you have n-dimensional data, the number of scatter plots in pair plot is nc2, right? So as n increases to 10 or even 100 dimensions or even 1000 dimensions, pair plots will not work. So how do we visualize and understand data which is very high dimensional? For that, what we do is, of course, we humans don't have an ability to visualize anything more than 3D. So what we do is, if a data set lies actually in an n-dimensional space, we try to reduce the dimensionality of this data to typically 2D or 3D because we can visualize 2D and 3D spaces. How we do it depends on what we want to preserve. We'll look at a couple of very interesting techniques called principal component analysis and T-distributed stochastic neighborhood embedding. Don't panic with these fancy names. They're very simple ideas. And we'll go over both these very, very interesting ideas of dimensional reduction. PCA is a very old technique, while T-SNE is almost the state of the art in visualizing high dimensional data. We will understand both of these techniques. And in this chapter, we will actually visualize a 784 dimensional data, just to give you a flavor of the type of problem we are trying to visualize. And the visualizations that we get with PCA and TSNE are terrific, trust me. Okay, so excited to learn dimensional reduction because when I first learned about ideas like TSNE, I said, wow, this is a brilliant piece of mathematics through which I can visualize extremely high dimensional spaces.